How do I use powers to represent repeated multiplication? Take a look at workbook page 167. We're going to talk about powers in this lesson. Some numerical and algebraic expressions and equations include powers. A power is an expression that includes an exponent and represents a repeated multiplication. An example of a power is 4 to the third power, which is read as 4 raised to the third power. A power consists of a base and an exponent. In a numerical expression, the base is a number, and the exponent tells how many times the number is used as a factor. Remember, a factor is just simply a number that gets multiplied. So we're saying that the base is being multiplied a certain number of times. In the expression 4 to the third power, the base is 4. The base is usually the bigger number. And the small raised 3 there, that's the exponent. The exponent tells you to use 4 as a factor 3 times. So here's what it would look like. 4 to the third power. Well, I want 4 to be the factor. I want 4 to be the number that I multiply. And I want it to be a factor 3 times, which means I need to do 4 times 4 times 4. That is not 4 times 3. That is 4 times 4 times 4. 4 as a factor 3 times. And when you actually multiply it out, 4 times 4 is 16. 16 times 4, that's going to give you the 64 here. So 4 to the third power is 64. That's very different than 4 times 3, right? In an algebraic expression, the base could be a variable. In the expression r to the fifth power, which is read r raised to the fifth power, the base is r, and 5 is the exponent. The exponent tells you to use r as a factor 5 times. So remember, that's not r times 5. We're saying, hey, r needs to be a factor. R needs to be a number that we're multiplying, and it needs to be a factor 5 times. So it would look like this. We have r times r times r times r times r. Remember, whenever you work with powers, you are working with expressions that represent repeated multiplication. Please keep that in mind. It's not repeated addition, it's repeated multiplication. So let's take a look at page 167, numbers 1, 3, and 5. We're going to write each expression as repeated multiplication. We're going to write it what we call expanded form. So we're not actually going to solve numbers 1, 3, and 5. We're just expanding out the problem to make sense of what it means. 6 to the second power means that 6, the base, needs to be a factor 2 times. So all you're writing on the lines is 6 times 6. You're just writing it as repeated multiplication. For number 3, we have 13 to the second power times 4 to the fourth power. Let's start with 13 to the second power. That is 13 as a factor 2 times. 13 times 13. 4 to the fourth power means 4 will be our factor 4 times. So that's 4 times 4 times 4 times 4. And because we're doing 13 to the second power times 4 to the fourth power, we need to have a multiplication sign in between them. And number 5, a to the fifth power. A is going to be our factor 5 times. A times A times A times A times A. So it will look like that. Now for number 7 and 9, we're going to use an exponent to write each repeated multiplication. So for number 7, it looks like we have 2 as our factor 4 times. So that's 2 to the fourth power. And in number 9, we have 2 times C times C. We'll look to see what is the number that is actually, having the repeated multiplication. That's C times C. That's where you see the repeated multiplication of C. So 2, there's only one 2. But you see C is being repeated twice. So 2 times c to the second power. Okay. Exponents and the order of operations. If you remember in the last video we talked about the order of operations, and I mentioned during the takeaways that there was one step that we didn't really include because it wasn't really covered in any of those numerical and algebraic expressions. This time we are going to cover it, and that is simplifying your powers. So if you notice in your workbook page 168, it's been added in as step 2. It's going to come after you do everything in the parentheses. Then you worry about the powers. And then you do the other steps. You multiply and divide, again, from left to right. And you add and subtract from left to right. So take a look at number 11. We have 4 plus 3 to the second power. Let's go through the steps. Are there any parentheses? Nope, so I don't have to really worry about step 1. Do we have any powers? Yes, we do. We have 3 to the second power. Which, remember, 3 to the second power is 3 times 3. It's 3 as a factor 2 times. So 3 times 3 is 9. And now I'm ready for step 3. Any multiplications and divisions? Nope. And addition and subtraction comes last. 4 plus 9. And we get 13. Then we're going to do it all over again. For number 7. Number 7 we have, let's see, 7 minus 2 in parentheses to the second power. So step 1, perform all operations inside parentheses. 7 minus 2 is 5. And that, if you notice, that power of 2, or that exponent 2, is attached to everything in the parentheses. So since we did what was in the parentheses and got 5, now our 2 is attached to the 5. So step 1 is complete, and now we're ready for step 2. We're going to simplify the powers. 5 to the second power, you know, is 5 as a factor 2 times, 5 times 5, which means 5 to the second power is worth 25. Step 2 is complete. We don't really have to worry about steps 3 and 4. The answer here is 25. And if you look at number 17, remember when we evaluated algebraic expressions where we had to substitute a number in for the variable? You're going to do the same thing here, except now we have powers involved too. In number 17, we have 3 times a to the third power. So first I'm going to do the substitution step. A is 5 in this case, so every time I see an A, I'm going to put a 5 in its place. Now I have 3 times 5 to the third power after completing the substitution step. And now I'm ready to solve it. Now I'm ready to simplify it. Let's see. Any parentheses? Nope. So step 1 is done. Powers? Yes. We've got 5 to the third power, which is the same as 5 times 5 times 5, because I want 5 as a factor 3 times. 5 times 5 is 25, and then 25 times 5 is going to give me 125. So now I have 3 times 125, because that's what 5 to the third power is worth. And now all I have left is, I gotta check off my simplify powers. All I have left is my multiplications and divisions, well, just multiplication in this case. 125 times 3 is going to give me 375. Let's take a look at your takeaways. First, we have the definitions of a power. Remember, a power is basically, an expression that includes an exponent and represents repeated multiplication. Remember, powers represent repeated multiplication. So the example here is 4 to the third power. The base is usually the bigger number. It's a number, or it could be a variable, that's raised to the power. So in 4 to the third power, 4 is considered the base. The exponent is that little small raised number, and that tells you how many times to use the base as a factor. And this is very, very, very important. I want you to make sure that you highlight this or put a little asterisk. Make sure you know the difference. Multiplication, We use that to represent repeated addition. You probably learned that, a couple grades ago. For example, instead of doing 3 plus 3 plus 3 plus 3, that's the same as just doing 3 times 4. We're saying, oh, we have 3 that we're adding 4 times, so just do 3 times 4. So multiplication is used to represent repeated addition. However, powers are used to represent repeated multiplication. So instead of 3 times 3 times 3 times 3, we would write that as 3 to the 4th power. So make sure you understand the difference between the shortcuts. Multiplication is used for repeated addition. Powers are used for repeated multiplication.